P4.2 current and charge. So this is the second part in this topic. So I'm going to go through and describe how they're related to some of the things we talked about in the first one. So a circuit diagram shows how components, so how parts in a circuit are connected together. This is a very basic circuit diagram. You've probably seen something like this in year 7, and you should know that this is a cell and this is a bulb. So this is a very basic single loop circuit. So each component has a symbol. You need to make sure you remember and recognise these symbols and what each component is used for. So what I'm going to do now is talk through what all the different symbols mean. I started off drawing them, but I thought it easier to show you the picture in the book. What you may find useful is actually to pause the video at this point so you can make notes and have a look at the different parts. I'm just going to talk through them quickly. So I'm going to start at the top left. So this is a cell, and it is necessary to push electrons around a complete circuit. I'll explain a bit more what I mean about push electrons around in a minute. A battery consists of 2 or more cells. Don't get a cell and battery confused. That's a very common error. A cell is different to a battery. 2 or more cells make a battery. The plus symbol, so the positive symbol next to the long line of the cell, indicates that it is a positive terminal end of the cell. So we think about it as a battery, there's a positive and negative end. It's a similar sort of thing. This represents the positive end. And the next one, you should know this one and be familiar with it, is a switch. A switch enables the current in a circuit to be switched on and off. Next one is a bulb. So an indicator such as a bulb is designed to emit light as a signal when current passes through it. This one is a diode. You might not have heard of this. A diode allows the current to go through in one direction only, and it's important because if it goes through a different direction, it can sometimes damage or break the piece of equipment that it's travelling through. This symbol is a light emitting diode, so an LED. Emits light when a current passes through it. A circle with an A in it is an ammeter, and this is used to measure the electric current. Again, that should be familiar to you. Coming down this side now, a fixed resistor limits the current in a circuit, so it can, if for example we limited the current in a circuit with a light bulb in, the slower the current, the lower the current, the dimmer the bulb would be, and we could move the resistors slightly bit on the resistor up and down, and that would change the current going through and therefore the brightness and dimness of the bulb. So a variable resistor does, so a fixed resistor just keeps everything the same. A variable resistor will make the bulb go lighter and dimmer, similar if you've got a light switch at home that dims or brights a light bulb on the wall. So that's what would be in it. So a variable resistor allows the current to be varied, fixed one the same. A fuse is designed to melt and therefore break the circuit if the current through it is greater than a certain amount. So there'll be fuses in all your plug sockets at home, and you'll have a big fuse box for your house. If too much electricity or current comes through, it will burn so that it stops it going through and it sort of keeps it safe. So this is a heater, and it's designed to transfer energy from the electric current to heat in the surroundings. And the last one, a voltmeter, which is used to measure the potential difference. So like I said, it might be easy for you to pause this video and have a look at them in more detail. Okay, talking about electric current now, so I'll explain a bit more what I mean about the flow of the current and push. So an electric current is a flow of charge. Each electron carries a negative charge. We should know this from our previous video when we looked at what charge electrons, protons and neutrons were. Metals contain lots of electrons, that's why they can conduct electricity easier than non-metals. And these move freely between the positively charged metal ions. Remember that an ion is just a charged atom. The electrons stop the ions moving away from each other, so it keeps them together. So the size of an electric current is the rate of flow of electric charge. This is the flow of charge per second. So just make sure you understand that. So the size of an electric current, how big it is the rate of flow. Okay, so the bigger the rate of flow, the bigger the size of the electric current. And this is measured in charge per second. So the bigger the number of electrons that pass through each component, so each part of the circuit, each second, the bigger the current passing through it. So again, I've got a simple diagram here, and it shows the direction of the electrons. So as I said earlier, the electrons move away from the negative terminal and towards the positive terminal. Remember, opposites attract, so it would be going around this way in the circuit. Okay, so electrons pass through the bulb because it is in the circuit, and the bulb filament, so the bit that lights up, is metal. So when the electrons get to here, because it's metal, it can transfer through it, and it lights it up as it does so, and then goes around to complete the circuit, so it gets back to the positive terminal. So this is a single closed loop circuit. The current is the same at any point on this, so if I measure the current here or here, it would be exactly the same. This is because the number of electrons per second passing through it is the same. So the number of electrons that are passing through here is the same as the number of electrons passing through here, because it's all got to go through the same direction. It can't go backwards, all needs to go through the same direction and keeps going round in the cycle. And then final bit, just to remind you what some of these means. So electric charge is measured in coulombs, and this, the capital C, is what the symbol that represents it. Electric current is measured in amperes, or we more commonly use the word amps, and that is represented by capital A. An electric current of 1 amp is the rate of flow of charge of 1 coulombs per second. When there is a constant current in the wire or component in a circuit in a given time, then we can use these equations. So if I wanted to work out charge flow, I could multiply the current by time taken. And I can see there's lots of letters here. So these are the units. So the unit for charge flow is coulombs, the unit for current is amps, the unit time taken is seconds. Now each of these have a letter that represents them. So this letter represents the unit. These letters here, these represent sort of the names of these different parts here. So remember, capital Q, capital I, lowercase t. It's very important that you get these the right way around, because sometimes capital T or whatever will mean something different. And then this equation can be rearranged to work out current and time taken as well. And we can use the equation triangle to remember that. So remember, if it's at the top, it's divided because there's a line in between. So for example, I know that Q is I times T, because it's multiplied. I know that time is going to be my charge flow divided by my current, and if I wanted to work out my current, I'd know that would be charge flow divided by time.